Hi everyone, welcome to the .NET Framework tutorial for absolute beginners. I'm Amog Nathu. This is the second in the series of .NET Framework tutorials for absolute beginners that I have posted here. In this series of videos, I will mainly explain about the .NET Framework and all the basic types of applications that can be developed using .NET. And while doing so, I will be using C# as the programming language. The series is mainly targeted to developers who are new to the .NET Framework. Well, in my previous video, I have introduced to you what .NET Framework is and what are the flavors that it offers and what are all the features that are provided to the developers by this framework. Now coming to this video, the second video, I will continue from where I stopped and start off with the design features of .NET. Then I will explain the framework architecture and also the different components in the architecture along with a few code samples. So the main things that I'll deal here is the architecture, the common language infrastructure, the common language runtime, the class library, common type system. Then I'll talk about memory management and I'll end the session with application domains. Coming to the design features of .NET, the first and foremost design feature is the common language runtime engine. Now in my previous video I have explained that applications that are developed in .NET run in a software environment. Now this software environment is actually the common language runtime, which serves as the execution engine for the .NET framework. Now all .NET programs execute under the supervision of the CLR, which guarantees certain properties that are required for the application to run correctly. Some of the properties are nothing but automatic memory management, security and exception handling. The next is language independence. Now like I said in the previous video, the main motto of developing .NET framework was to allow language interoperability. So to make the behavior of the applications independent of the language, programming language that they are coded, the .NET framework introduces something called common type system, which I will talk about in some time in this presentation. Now because of this feature, the .NET framework supports the exchange of types, data types, and as well as object instances between libraries and between different applications. It is not necessary that those applications are to be coded in the same language. Say one application can be coded in C# as well, and then the other application can be coded in VB, but if they are following the common type system standards, they can interact with each other and send object instances among between each other. So that's a little about language independence. Next, coming to the base class library. Base class library is part of the framework class library that is provided by the .NET framework. This is nothing but a library of functionalities that are available to all the languages that are conforming with .NET framework standards. Basically these provide classes that encapsulate common functions like maybe you have file IO reading, graphics, rendering, database interaction, you might have XML document manipulation. So these common functionalities are already provided in this base class library so that the developer doesn't have to write all these features again. And again these are of type, this consists of classes, interfaces and or many different reusable types that again all integrate with CLR. And the next design feature is the simplified deployment. It's simplified deployment. This is nothing but, like I said in the previous video, there are tools which the .NET framework provides which help in very easy deployment of the applications by almost a click of button. So that's how easy it is, the deployment part. Also the security, .NET provides a common security model for all the application, and it also addresses some vulnerabilities such as buffer overflows which could have been exploited by malicious software. So .NET provides security against all of these. And the next is portability. Now Microsoft has engineered this framework to be platform agnostic, and cross-platform implementations are available for other operating systems as well. Now this makes it possible for this third parties to create maybe compatible implementations of the frameworks and its languages on other platforms as well. So that's a brief about design features of the .NET. Next I will move on to the architecture. This is the architecture of the .NET framework. Now if you see from the bottom of the screen, at the bottommost level you have your operating system, which is Windows, and other complex services that constitutes the bottommost part of the architecture. Above that you have the common language runtime, which I just talked about. This is nothing but our execution engine. This is where all the applications are running. Above this you have .NET Framework base class library. This is what I was telling, the common functionalities that are provided by default with the framework, and the developer doesn't need to code all those functionalities again. You have classes for ADO.NET. This is basically for interaction with the databases. I will talk about this in the further videos. Then you have classes for XML, you have classes for threading, IO, network, security purposes, diagnostics. Over this you have ASP.NET as well as Windows Forms. These are parts of presentation layer. ASP.NET is basically for developing web UI, web pages, and Windows Forms is basically for client side applications. Above this you have common language specifications. Common language specifications is nothing but a set of standards, rules you can say, that are provided by .NET Framework, which all of these top level languages should follow in order to have language interoperability. I will talk about this soon, immediately. And to the right you can see Visual Studio.NET. Visual Studio.NET is the IDE, as I was talking in the previous video. This is the IDE that helps in very easy development of .NET applications, and it encompasses all of these layers into itself. So you can very easily develop and deploy applications that you have developed in Visual Studio. This is another I will say diagram of the architecture. It's the same. There's not much difference between that, just that here in the middle portion they have just separated the ADO.NET and XML layer. There's not really much difference. Both of these I have taken from the internet directly, so it's pretty much the same. There's no big difference between the previous architecture diagram and this diagram. Now if we move on to the common language infrastructure. The common language infrastructure's purpose is basically to provide a language neutral platform for the application development. So like I said, application developed in one language should be able to communicate with application developed in second language. So what this means is that the common language infrastructure, CLI, specifies a set of standards that all the languages supported by .NET must follow for the application to become language independent. So basically CLI is nothing but a set of rules that are given to all the programming languages, so that if you develop your application which is conforming to all the rules, your application can indeed interact with or send objects to or instantiate objects of another application which is developed in some other programming language. So if you see this diagram here, at the top level you have the programming languages C#, VB.NET and other CLI conforming languages. Each language has its own compiler. C# has its own compilers for C#, VB has its own compiler, and other languages have their own compilers. But all of these compilers compile the code into a common intermediate language. Now this is called CIL. it is also called Microsoft Intermediate Language, MSIL. So for now I will call it as CIL. So what happens is, be it any programming language or be it any compiler, it will compile the code into the same common intermediate language, and this intermediate language serves as the input to the common language runtime. And at the common language runtime, in the common language runtime, a process known as just-in-time compiler will take this common intermediate language and convert it into machine level language before executing the application. So that's the process. So it starts off with the programming language of your choice and the corresponding compiler for that language. Then it converts into the common intermediate language. That is the input to the common language runtime, and common language runtime converts that into the machine level code for executing the application. So this slide I will talk in this slide I'll talk about common language runtime specifically. It is pretty much the same as the previous slide. You can see the programming languages to the side. It's a source code, and each has its own compiler that compiles the code into the bytecode, common intermediate language codes. You can see it as CIL code, and then during runtime the CLR takes over and the native code is generated. Now CLR is basically, like I said previously, it is the virtual machine component of the Microsoft .NET framework, and that is responsible for managing the execution of your program or application. Now in the CLR, a process called just-in-time compilation happens, and just before the execution, this just-in-time compiler, it's called JIT compiler, it transforms your bytecode, intermediate language code, into the native code for execution. Apart from this, the CLR also provides some other functionalities or features, you can say, like automatic memory management, type safety, and also exception handling. I will talk about memory management soon, but for now I'll stop here. And other than that, another thing I wanted to say was, no matter what your programming language is, it will finally end up in the same CLR. There is no different CLR for each programming language. Be it any programming language, the bytecode will enter into the same CLR. So that's one point to be made a note of. So next, if you go on to the class library, like I said, class library is nothing but it includes a set of standard class libraries that provide a large number of commonly used functions. Generally, most of these APIs are part of system namespace or Microsoft namespace. I hope you have an idea of namespaces. So these class libraries basically implement a large number of common functions for reading, writing files, I/O, graphics, databases, connectivity, and other stuff. The .NET framework is this framework class library. Class library is basically logically divided into two: base class library and the framework class library. I will say that the base class library is a subset of framework class library because it provides the basic level API for CLR, whereas the framework class library is a superset of BCL, and it refers to the entire class library that includes all the other types of common functionalities as well, including functionalities for Windows Forms, for ADO.NET, for ASP.NET. Then you have something called LINQ, language integrated query. So all the common functionalities for all of those are included into the framework class libraries, whereas the base class library holds common functionalities only specific to the CLR. Okay, so that's about it in class libraries. We'll move on to the next one. Next one is common type system. Now, like I said, common type system is nothing but it is used to fully interact with other objects regardless of the language that other object is coded in. In order to do that, this Microsoft has defined CLS, Common Language Specifications, or which is nothing but like guidelines for languages to follow so that they can communicate with other .NET languages in a very easy way. So you don't have to struggle a lot for inter application communication. So like in the common type system, say you have say take an example of data type int. Now most languages accept this, but there could be one imaginary language or maybe future language which has some other keyword analogous to int. So if say our application wants to communicate with this new language, both of these applications should use int 16 or int 32 or other appropriate types specified by CTS. CTS is common type system. So CTS specifies a common type definition for all these. So for int int keyword you have int 32 or int 16, that depends. So if you want two applications to communicate with each other, you should use this int 32 or int 16 instead of using just the keyword int. So that's just one example. Now some of the functions of a common type system is basically, first is to establish a framework that helps cross language integration. So that's the main point, right? That's the main point of developing a common type system. Then next is to provide object oriented model for that supports complete implementation for many different programming languages. Next is to define rules that these languages must follow, to which basically helps to ensure that objects written in any language can interact with each other easily. Apart from this, it also defines some rules that the data types of these objects should follow. This is nothing but the example that I just said. And then you also have rules for types, visibility and access to members of a type. So this is quite in depth, you don't really need to know all this for now. And then I guess that's about it for common type system, because I don't think there is much in here to be spoken of. The only thing to remember here is that common type system specifies the rules that should be followed. Like if your application is going to interact with some other application which is written in some different programming language, then you have to make sure that you follow all the rules specified by common type system. So okay, next we will move on to this. Yes, common type system has two types of defines two basic types. First is the value types, and then you have the reference type. Value types are nothing but they directly contain the data. So if you have say variable int x equal to 30, the memory location of x will directly have the value 30. And for the memory for this value types is allocated in the stack, and some of the types of value types are built-in types, user-defined types. I'm sorry for the pause. It's built-in types, user-defined types, enumerations, and then you have the reference types. Reference types are nothing but they hold a reference to the actual value. So say if you have reference type variable equal to something, so that will not directly hold the value, but it will actually hold a reference to the value. Now for reference types, the memory is allocated in heap, and some of the examples are arrays, class type, pointer types, etc. Now difference between a value type and reference type, for that I will show the same program in code. Yeah, this is the code that I've written, just a sample code. For now, don't try to understand this. I'll just show you the main portion here. This is the thing that you need to concentrate on. For now, forget the syntax. In the start, I've declared two variables. These are value type variables because they are of type int. This val1, which I have assigned to 0, val2 which I have assigned to val1. So now at this point, both val1 and val2 have the value 0 in them. In the third line, I am assigning the value 1, 2, 3 to val2. So what happens internally is the memory address which is storing the value of val2 will directly hold 1, 2, 3. Coming to the next line, I have defined a new variable called ref1, which is of type class1. Now class is a reference type, so this variable ref1 is of reference type. And then I have declared another variable ref2, and I am assigning ref1 variable to ref2 variable. So in this line, what exactly is happening is ref2 is a variable that is created, say, at memory location 2000, and ref1 is a variable that is located in the address location of 1000. So after this assignment, ref2 will hold the address of ref1. So ref2 will hold the address, that is 1000, of ref1. So in actually what it means is ref2 is just pointing blindly to ref1. They are pretty much the same. So any changes that are made to ref2 will automatically reflect in ref1 as well, because they are nothing, it is nothing but ref2 is just simply pointing to ref1. So because I have assigned some value 1, 2, 3 to ref2's variable, it is internally actually being assigned to the ref1's value itself. So in the next lines, when I print the values, we will see what the output is. So for now I am just running the application. So if you see here, val1 is 0 because I haven't changed the value of val1. val2 is 1, 2, 3. I have assigned it here. Then coming to the reference variables, you can see that ref1's value is also 1, 2, 3 and ref2's value is 1, 2, 3, but in the code, if you see, I have not assigned any value to ref1. I have only assigned to ref2, but because ref2 was directly pointing to ref1, the changes in the value assigned to ref2 also have reflected in the value of ref1 as. So that's just one small example related to value types and reference types. This is just a small diagram. You can see this. First is the type. There are two types: value types, reference types. These are the three types of value types. Then you have different types of reference types. You can see this. It's not really important for now, so I'm moving on to the next one. There is one concept called boxing and unboxing that is specified in common type system. Now boxing, it's very simple. Boxing is nothing but converting a value type into a reference type. So here if you see, I have defined a variable int32 variable equal to 500. Now I want to convert this into an object type. This is nothing but, this is actually a value type. It is directly storing the value of 500, but I want to convert this into reference type. So because object is a higher level class than int32, it will directly accept the value here with this assignment. So it's called implicit boxing. Now unboxing is nothing but the reverse process, that is converting a reference type back to a value type, but there is actually, you know, you can't implicitly unbox, you have to do it explicitly. So say you have a variable equal to 600. In the next line I'm doing a implicit boxing, so this variable is being converted into a reference type, and to convert it back I have to typecast the object into its corresponding value type. So now when I'm reassigning the value back to variable, I have to typecast it into an integer, because object is a higher level and integer is a lower level type. I have to do this explicit typecasting. Implicitly it doesn't work. So this is just something about boxing and unboxing. Next is memory management. The best part about .NET Framework is that, you know, the developer doesn't have to manage the memory in the code explicitly. .NET Framework will automatically do it for him. So basically how it does is it detects the memory that is being not being used, I would say. Basically it detects unused memory. Because instantiations of .NET types or objects are allocated from the heap, so this heap is managed by the CLR, and it continuously keeps monitoring the heap to see if there are any objects that are unused. Now as long as there exists a reference to a particular object, which may be direct or indirect reference to the object, it is considered to be in use. Now the moment all the references to objects are gone, the CLR detects that the object is not being used, and it tries to take up the memory of that object. So basically when there is no reference left for the object, it becomes eligible for garbage collection. So garbage collector is something, it's a background process, and it runs on a separate thread and doesn't run on the same thread as your application. So it doesn't cause much of a performance loss. Of course there is a bit of performance loss, but it is negligible. Now what the garbage collection does is it maintains 3 generations of objects. What this generation means is you have 3 generations, 0, 1, 2. So when an object is newly created, it is automatically assigned to the generation 0. And because garbage collection runs periodically, now suppose if the newly created object survives first run of the garbage collector, so it means that the object is still being used. So because it is still being used, it is moved to the next level generation, that is generation 1. Again after some time when the garbage collector runs, and again if the object survives, it means that still the object is being used. So now it is moved to generation 2. This is how it happens, and after some time, after it moves to generation 2, now only after the object has been released, or maybe all references to the object are lost, only then it is removed. So that's how it cleans the objects. Another way of garbage collection is mark and sweep strategy. This is nothing but garbage collector builds a graph of all the objects that are being used in the memory, and it tries to find a path that covers as many objects as it can through the graph. So it basically forms a path from the first object, and it tries to cover all the objects in the graph. But of course it cannot cover all the objects, because some objects might not have any references to them. So such objects which are found to not have any reference to them are garbage collected immediately. So this is nothing but the mark and sweep strategy. Next is the application domain. This is the final topic of this video. application domain is nothing but, each application that you are running in the CLR runs inside its own application domain. It is kind of like application domain is nothing but a secure method of isolating your application. These are usually created and manipulated by this runtime hosts in the CLR. What it helps is it mainly provides security and separates the applications from each other, and doesn't allow the data interference between the application. Now a single process inside the CLR can actually have several application domain but internally one application domain will not communicate or interfere with other application domains data. So the main advantages of this is that faults in, suppose a particular application fails inside one particular application domain, that will in no way affect any other application domain that is running inside the same process, because each application domain is isolated with the other. And in the same way, individual applications can be stopped without stopping the entire process. So if you can just turn off one application domain, or you can very easily do that without stopping the process. So that's one really good thing. And also the code that is running inside one application domain cannot directly access the code of another application. You need to do some other stuff. It's called .NET remoting. You don't really need to know that right now at this point. So that's the thing. And behavior code is scoped by the application in which it runs. So you can specify some particular type of configuration settings for one particular application inside the application domain. So configuration settings are nothing but the behavior of that particular application. So that can be easily specified in the application domain. And not just that, even permissions granted to the code can be controlled, because again application domain is separate. You can provide some particular permissions to a particular app domain and some other permissions to other application domain, and they will not interfere with each other. So that's just brief about application domain. Just remember that every application will have its own application domain in which it is running. This is basically to provide isolation to the application, and so that it is safe from data interference, and provides a little bit of more security. So I guess I have come to the end of this session as well, and in the next video I will start off with the first basic .NET application. Sometime back I showed you the application, right? So I will explain with a much more better Hello World application. I will explain each and every part in the code. Then I will start off with the C# programming language. I'll introduce the language, then I'll talk about the language constructs and other things. Then I will also explain the basic console application using .NET. So from the next session I will start off with the type of applications that you can develop in .NET framework. I will start with the very basic one, that is nothing but a console application. Console application is a DOS type application. The previous application which you saw that I just run some time back was nothing but a console application. So I will explain that, a basic console application, and I'll also show some other examples of those as well. So thanks for watching, guys. Thanks for taking out your time and listening to this video. I hope it was useful, and if you find it useful, please do subscribe to my channel and also to my blog. I keep blogging on that regularly. So thanks a lot, guys. Thank you. Hope to see you again.